Good day, ladies and gentlemen. This is Watson Michael from Ceylon Institute of English and Leadership. And today we have with us Mr. Rob Gillard, a senior consultant who is well experienced in sustainability. Also, he is a fellow of the Global Evergreening Alliance and European Climate Pact Ambassador of the European Union. So, Rob, welcome, and how are you doing today?
Yeah. Hello, Watson. Thank you for having me. I'm doing fine, and I'm not so far from you actually. And I'm in Chennai, South India right now,
Yeah.
where we're actually having a very nice, cool summer comparatively.
Great, great, yeah, great to hear that. So, Rob, let's start with what is biodiversity and why does it matter?
Yes. Let me start first why it matters
Yeah,
in
sure.
a general sense. All life matters,
Yes.
and there is an intrinsic value to life.
Mm,
I mean, we never ask why a human matters.
mm,
It's intrinsically a value that they are alive, and that goes basically for all living beings on our beautiful living planet. So let me
yes.
state that straight away. Um,
Mm,
and biodiversity, I think the reason why we are so biodiverse is because life has been busy bioengineering, let's say, certain
mhm.
circumstances on this earth for the last 3.8 billion years.
Okay.
And it has taken its time to come up with beautiful solutions to create the conditions for life to thrive.
Hmm.
And especially in places where there's a lot of sun, like in the tropical countries, so there's a
Yeah.
lot of heat coming in from the sun. All kinds of mechanisms have been found to um, keep the temperatures within certain bounds,
Yes.
keep the places irrigated so that life could thrive.
Hmm.
So, and in that, like in our own body, a lot of species work together to get exactly these effects.
Yeah.
If you take a soil sample, a friend of mine at Yuling at Princeton University,
Hmm.
he showed me a monster, and he said, so far we have discovered 800 different types of bacteria and fungi
Yeah.
just in this little bit of of soil, and that is exactly what gives it its vigor. They're
Mm.
working together. There's a diversity in it that somehow becomes a system of beautiful resilience.
Yeah.
Biodiversity is resilience.
Yeah. Wow. So, yeah, based on that. So, like, now deforestation needs to stop, but we don't, but it doesn't seem to stop. We have noticed like many indigenous people are being affected by it, and many large foreign organizations seem to be a part of it. So the carbon profits also they are invested in restoring forests in certain parts. So what are your insights on that?
Well, in general, um, our economic system
Mm,
um, does not incorporate the damage that we do to our planet. So
yeah.
if industries would have to pay for the damage that they do
Mm,
to our planet, basically a lot of industries would not be profitable.
yeah.
The so-called externalities are simply not paid. And we all know that if you, for instance, cut down a beautiful tropical rainforest with all the
Mm,
species in it, not only does it take away a lot of beauty,
yeah.
it actually takes away a lot of cooling.
Mm,
It takes away water management because
yeah.
forests actually absorb water and let it go slowly.
True.
So the effect of this destruction of ecosystems translates into extreme weather,
Mm,
uh,
mm,
heavy rains, terrible floods,
yeah.
high temperatures, and with that actually affects our health,
Yeah.
but also, for instance, our food production. And
Yes.
all of this is not paid by the companies who are making, who messing with that, with
Yeah.
basically what is
Yeah.
our common, is our common good.
Mm, mm. Yeah, because if you just look at the Guardian, I mean, when it comes on the climate crisis section, there are many clauses about the current climate crisis and what is happening. So they give a lot of information. So now, like some people and certain organization, they don't seem to understand that the ocean matters, because pollution with materials and like certain chemicalized fluids and those kinds of things like cause huge catastrophes. So what are your views on ocean warming and marine biodiversity being threatened?
First of all, it's very simple. Two-thirds of the planet is water. So
Mm,
what happens there somehow affects us. But because we are, except for maybe a lot of fishermen people,
yeah,
we are not on there. So at most we go to the beach. So that it's not top of mind. However, what happens in the oceans indirectly and directly. And
yeah,
there's one thing. There's a couple of things I would like to say.
yeah, sure.
There's clear scientific evidence which has come around maybe for the last 10 years or so, a bit more.
Mm-hmm.
First of all, that all ecosystems,
Yeah,
including, for instance, coral reefs, but
yes,
also
correct.
algae bloom,
Mm-hmm.
they create, they give off certain particles into the atmosphere, which are the condensation nuclei for to form rain.
Yeah,
So
wow.
actually, a coral reef, if it's healthy, makes clouds and increases the amount of precipitation. And when it makes clouds, it actually forms an umbrella that reflects solar heat that's coming in, and
Mm,
so it goes out. You have more clouds. In general, you could say it cools the planet. So
yeah.
that's just an example.
Mm, mm,
Another thing that has been only recently understood is that
yeah.
while we know that for good food production and for
Mm,
healthy ecosystems, we need good soils.
yes.
There's some equivalent to what you could call soil, and it's the sea surface microlayer. There's
Mm-hmm.
a small, quite often just micron thick layer of biologically active
Yes.
material on the top of all oceans that
Mm-hmm.
interacts with the basically is it's the it's it's the limit between atmosphere and a healthy
Yeah.
surface layer is actually very important for instance, the amount of evaporation
Yeah.
and the heat exchange.
Yes.
The same also, we could say that I think many people know the story, for instance, how
Yeah.
whales actually help to fertilize the oceans.
Okay.
And with that, increase biomass productions, particularly
Mm.
for plankton and algae.
Okay.
And this basically makes for a lot more bioactivity within the oceans.
Yes.
So a healthy ocean is extremely important for also for fish,
Yes.
for the amount of fish in the seas, etc., but also for
Yeah.
the regulation of temperature and
Mm.
cloud forming over the oceans.
Yeah.
Warming oceans obviously have all kinds of strange effects, especially you see already the migration of species.
Mm-hmm.
We see the coral bleach events that happens if there are certain
Yeah.
thresholds of temperature. We go past that in places like the Barrier Reef in Australia or
Mm-hmm.
parts of of Indonesia and stuff like that,
Yeah.
which it takes a very long time to repair that damage, often decades, if the water stays cool enough.
Mm-hmm.
And the largest part is, of course, the ocean. The rising of the sea is
Yeah.
right now is half of it is basically the expansion of water. So the rising seas is in part caused
Mm.
by water expanding. So and
Yeah.
that's threatening our coasts.
Absolutely. So, Rob, now with this water sea level rising, supply chains could be disrupted, right?
Yes, well, we see right now the whole global economy is incredibly interdependent, and we see all kinds of supply chain disruptions. In it, not just it's in a sense it's a wicked problem because it's not manageable and it can happen in so many ways,
Yeah.
um, and um, and it can affect people on the other side of the world. What
Mm.
happens on one side of the world? So yes, that's definitely possible. We we've seen, for instance, if you get food price rises,
Yeah.
that quite often leads to unrest,
Yes.
which leads to disruption in supply chains because there is strikes and there's conflict, etc. So all
Yeah.
these things hang together.
Yeah. Very true. Very true. So I think mangroves will help a lot against this rising sea level, right?
Yes, or I would say that all coastal marine ecosystems actually can help with these problems. But the mangroves are particularly important. First of all, because they are sort of the nurseries for both the oceans and for species on land and for birds. So they support a lot of biodiversity. They're the shock breakers for storms. Um, and that is quite often is not really understood. But if you go to a large mangrove area, it's quite often it could be kilometers deep. So even the tsunami, of course, Sri Lanka was hit by one in 2004.
Yes. Yes.
Even a tsunami will be slowed by a large, healthy mangrove forest. Apart from that, it sequesters a lot of carbon. I mean, if you grow a mangrove forest, you see that there's roughly like 28 tons per hectare per year of
Yeah.
CO2 being sequestered
Yes.
in a growing mangrove forest. So incredibly important ecosystem. Yes.
Absolutely. Very true. So, like, what type of a strategy, like, on your views from your experience and everything, what type of a strategy would you recommend, like, to reduce global warming? Because some sources say that we may cross the 1.5 degree Celsius mark in less than a decade.
Yes, and that it's probably going to happen already in some places in the next 18 months or so, because you see both an El Nino
18,
brewing. You
sorry,
see,
Rob, within 18 months or so.
yeah, I'm not saying planetary wise,
Okay,
but
okay.
if you see, for instance, the El Nino of 1989,
Mm-hmm.
it actually was a peak year in global temperature, and for 10 years it was that record was not taken over by the slow warming, because especially the El Nino let out so much heat into the atmosphere.
Yeah.
And I think we're going to have a bumper El Nino, but on top of already very high sea surface temperatures in the northern Atlantic.
Mm.
Um, and together, there were a couple of articles around, including The Guardian, just a week ago or so, and it showed that we are actually at the moment at unprecedented high temperatures, and they were going up fast.
Mm.
So it's very interesting, and we're talking then aggregate temperatures over the whole planet of sea surface temperatures. Yes.
Yeah. So, like, what type of strategy would you recommend? Like, we reduce the global warming on your point.
Well, everybody's focusing on carbon, and
Mm.
I'm not saying that carbon is not the way to go, but it's a very one-sided strategy, and it doesn't take into account that the world works differently. You could say,
Mm.
I was just mentioning a couple of things about healthy marine ecosystems. If
Yes.
you look, for instance, at tropical rainforests, they have been designed basically over the last 100 million years or so um, uh, to evapotranspire a lot of water. And what does that mean? At the moment they transpire water, at the moment that they are doing photosynthesis, basically they're capturing energy. And you know that if you put the kettle on to boil a cup for a cup of tea, it needs a lot of energy to
Yeah.
make a liquid water into gas.
Mm.
But that is exactly what's happening in evapotranspiration. Large trees can do up to 1,000 liters of day, and they can evaporate that.
Mm.
Now that goes up into the sky. Up there, you have the lapse rate, so it gets colder,
Yeah.
and at some point there is a cold point, and it starts to condense. But it's
Mm.
not just condensing because of the colder temperatures. There's another thing that forests do, and actually all ecosystems do. They also exude small particles from their leaves,
Yeah.
which are called condensation, cloud condensation nuclei, and these particles are actually the platforms that form raindrops.
Mm.
So forests actually produce clouds and rain. Now we all know that rain, when it falls, it cools
Mm.
down. We also know that if we walk into a healthy forest, it feels cooler. The temperature is managed within that ecosystem.
Yeah.
And the last part, which is wholly unknown, it's only being discovered by scientists right now, is that at the moment of condensation at cloud level, water vapor actually gives off the heat that it has taken from the Earth's surface. And it does it in an infrared spectrum. Part of the spectrum is called the
Yeah.
atmospheric window,
Mm-hmm.
which means that doesn't get affected by greenhouse gases. So it actually radiates out into space. So forests are a two-step air conditioning machines, especially tropical rainforests. First, they take heat from the forest floor through evapotranspiration and bring it to cloud level, and there that heat gets goes in all directions, and half
Mm.
of that actually goes out into space. It's an air conditioner.
Yeah.
It's these are the cooling organs of our planet. So while we think it's all CO2 that is the culprit, and it is up to a point, we're basically destroying the cooling organs of the planet that have been evolved over roughly 100 million years to come to this powerful this powerful metabolism to keep the temperature right.
Mm.
It's very important. So you could actually say that by the biodiversity crisis and the destruction of ecosystems is the prime reason why we have not only extreme weather, droughts, heat waves, floods, big rain events, but
Mm.
also the reason why the temperature is going up. And it's attributed to CO2, and that's only a very small part true. And by the way, if you regenerate your ecosystems, we have been destroying roughly half of living biomass in the last 12,000 years or so, from 1,100 gigatons to 550 gigatons.
Wow.
If you recreate all that living biomass, you actually sequester a lot of carbon. So even people who don't believe this story could still get behind it because the carbon gets sequestered. Don't you worry.
Mm. Wow. Superb, superb explanations, Rob, right? So well articulated, right? Someone who is not aware of the current climate crisis or about the climate change occurring in several parts of the continent, I mean, the way you explained it, they would understand a lot, right? So, Rob, any final message to all the people who watch this podcast?
Yes, I got a good and a bad message. The good message is that actually, if all of us, and I'm talking really about a global movement of regeneration, if we all start to regenerate our important ecosystems and also transition from our right now destructive form of food production to sustainable food production, especially in the tropics in the form of agroforestry, if we do that fast and at scale, and I'm talking hundreds of millions of people that should be doing that, we can actually calm the weather. we get less droughts, less heat waves, less floods and rain events, and we get and the temperature will slowly surface off and can even come down. The
Mm.
bad news is, and I also like to stress that because people think that it's a gradual process, they're not alarmed enough. If somebody's on the IC, and you see them, all these tubes and all these machines doing all kinds of readings, you know that in the end, if things goes wrong, they go, um, they pass away because of multi-organ failure.
Yeah.
Right now, the large organs of this planet, like the Amazon rainforest, for
Mm.
instance, are at a tipping point, and once they go past the tipping point, like with coral reefs, they can't bounce back. Ecosystems are very good, like our bodies, are able to regulate certain certain impacts. But if it goes over a threshold, basically, it goes wrong.
Mm.
Same as, for instance, our own temperature. So I'd like to say the positive things. If we start a movement for regeneration globally, we, our children, are going to have a mighty good time on this planet. But if we don't, we're going to have the worst decade, the worst century in the history of mankind.
Mm. Very true. So, Rob, thank you very much for taking time and doing this podcast with us.
Thank you very much for inviting me, Watson. I'm very, very honored and delighted to be with you. Thank you.
No problem. Such an honor.